Welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISC² CISSP exam with focused explanations and practical context. In today's episode, we're focusing on input validation and output encoding, two foundational software development practices that play a critical role in preventing injection attacks and ensuring secure data handling. These techniques are especially important in a world where user-supplied data powers everything, from login forms and search bars to complex APIs and integrated platforms. Whether it's a script tag in a comment section or a malicious payload hidden in a query string, improperly validated or encoded data can compromise the integrity, availability, and confidentiality of applications. As a certified information systems security professional, you'll need to know how to manage data inputs and outputs securely to protect systems and uphold trust. Let's begin with input validation. Input validation is the process of checking user-provided data to ensure that it meets predefined rules for safety, correctness, and format. It's the first line of defense against malicious data and is essential in every software component that accepts input from users, external systems, or third-party services. When input validation is done correctly, it blocks malformed, unexpected, or dangerous data before it reaches core business logic, databases, or rendering engines. It helps prevent injection attacks, data corruption, and denial of service conditions. It also contributes to software quality by ensuring that applications behave as expected even when users, or attackers, submit unanticipated input. For example, if a form expects a user to submit an age, the application should enforce that the input is a number within a realistic range. If a field expects an email address, the input should match a known pattern for valid email formatting. If a parameter is used in a SQL query, it should be validated and parameterized to prevent injection. By proactively enforcing rules about what data is allowed, developers reduce the likelihood that unsafe data will be processed or stored in sensitive locations. Now let's examine how to implement effective input validation practices. The first step is to clearly define acceptable input. This includes specifying the expected data type, value range, length limits, and format. For example, if a field accepts only 5-digit zip codes, then inputs longer than 5 characters, containing letters or lacking digits, should be rejected. Use whitelist validation techniques. This means specifying exactly what is allowed rather than trying to block known bad patterns. Whitelisting is far more effective because attackers are constantly inventing new ways to bypass blacklist filters. Input sanitization can also be used, especially in situations where data must be cleaned rather than rejected outright. This involves removing or neutralizing potentially harmful characters, such as stripping out HTML tags or converting special characters into safe equivalents. Validate inputs on both the client and server sides. While client-side validation improves user experience by providing quick feedback, it should never be relied upon for security. All inputs must be validated again on the server side, where attackers have no control over the logic. Finally, document your input validation rules. Ensure that they're consistent across the application and that they're maintained alongside code updates. When development teams understand the validation logic, they can enforce it more effectively and reduce the risk of inconsistent enforcement or forgotten edge cases. Let's now shift focus to output encoding. Output encoding is the process of converting data into a safe format before it is rendered by an output medium, such as a browser or a database. The purpose of encoding is to prevent untrusted input from being interpreted as executable code, such as a JavaScript payload in a web browser or a query in a database engine. Where input validation acts as a gatekeeper, output encoding acts as a failsafe. Even if untrusted input reaches an output function, encoding ensures it's treated as content, not as instructions. The most common example of a vulnerability caused by unencoded output is cross-site scripting, or XSS. In XSS attacks, malicious users inject scripts into applications that are later displayed to other users. If output is not encoded properly, those scripts will run in users' browsers, potentially stealing credentials, hijacking sessions, or altering application behavior. Encoding neutralizes this threat. For example, converting angle brackets into their HTML encoded equivalents ensures that browser interpreters do not execute embedded scripts. The same goes for quotes, parentheses, and ampersands, which can all be part of XSS. Proper output encoding also supports secure application logging, API responses, and data exports. Anytime untrusted data is rendered in a new context, encoding ensures that it's handled safely and predictably. For more information on CISSP certification and other valuable cybersecurity education resources, please visit cyber.org.me. You'll find best-selling books, training tools, and resources tailored specifically for cybersecurity professionals. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Let's now walk through how to implement effective output encoding techniques. First, always apply context-aware encoding. The correct encoding method depends on where the data will be rendered. HTML encoding is used for browser content. JavaScript encoding is used when data appears within scripts. URL encoding is used in hyperlinks. SQL encoding is used for database queries, though parameterized queries are usually preferred. Mixing or misapplying encoding types can introduce new vulnerabilities. Use trusted encoding libraries. Many modern frameworks provide built-in encoding functions that are tested, maintained, and vetted for security. Leverage these tools rather than trying to create your own. Examples include Microsoft Anti-XSS for .NET or the OWASP Java encoder for Java-based applications. Apply encoding systematically across the application. Any field that displays user input, whether in a web page, API response, or log file, should be treated as untrusted and encoded accordingly. This includes usernames, comments, search queries, and any external data sources. Document encoding requirements clearly. Your secure coding guidelines should include specific rules about when and how to encode data. This helps prevent mistakes by developers, especially those unfamiliar with XSS prevention or output rendering behavior. And of course, train your developers. Encoding concepts are not always intuitive, and it's easy for well-meaning developers to make dangerous assumptions about what needs to be encoded. Training sessions, code reviews, and security awareness initiatives reinforce good practices and ensure encoding becomes second nature. Let's now examine the security controls that support validation and encoding. First, integrate automated testing tools into your development pipeline. Static code analyzers, dynamic scanning tools, and automated security tests can identify missing validation checks or improper encoding logic before code reaches production. Secure your development environments. Use version control systems that enforce code review policies, secure repositories that restrict write access, and integrated development environments, known as IDs, that support security plugins and syntax checking for secure coding. Conduct regular vulnerability assessments and penetration testing. These tests should include injection attacks, XSS attempts, and payload testing to validate whether input validation and output encoding are functioning correctly in all relevant contexts. Apply access control and encryption to sensitive workflows, protect user data during input and output handling, and ensure secure transmission of sensitive information using protocols such as HTTP. Maintain thorough documentation of your validation and encoding rules. Include threat models, known attack vectors, example exploits, and remediation patterns. This becomes a living reference for new developers and a key asset for audit readiness. And let's finish with continuous improvement in validation and encoding. Like all security practices, input validation and output encoding must evolve with the threat landscape and the technologies your organization uses. Regularly review your validation logic. New data formats, internationalization requirements, or updated application features may create new attack surfaces. Similarly, encoding libraries, must be kept current to address newly discovered bypass techniques or platform-specific issues. Use incident and bug report data to improve your rules and training. If a validation failure or encoding issue leads to a security incident, use that as a case study for internal education and process refinement. Collaborate across teams. Application security professionals, developers, QA teams, and business stakeholders must all be aligned on input handling expectations and responsibilities. Provide frequent training and secure coding refreshers. Use interactive examples, code walkthroughs, and real-world case studies to reinforce the value of secure input and output practices. Thank you for joining the CISSP Prepcast by Bare Metal Cyber. Visit baremetalcyber.com for additional episodes, comprehensive CISSP study resources, and personalized certification support. Deepen your understanding of input validation and output encoding, and will consistently support your journey towards CISSP certification success.